Hello and good day, everyone. Welcome back to my YouTube channel. This is Sir Marcy, and our lesson for today is all about how to solve radical equations. If you're new to my channel, please consider subscribing and hit the notification bell so you'll be updated with my latest videos. Alright, let's define first radical equation. A radical equation is an equation in one variable with one or more radicals. To simplify radicals, you may have to isolate the radicals and raise both sides to the exponent equivalent to its index. That is, if a is equal to b, then a raised to n is equal to b raised to n. In solving radical equation involving one variable, the following procedures are suggested. Number 1, isolate the radical in one side of the equation by applying properties of equality. Next, combine similar terms whenever possible. Next, get the nth root of both sides to eliminate radical signs. And we have to solve the resulting equation. Lastly, we have to check the solution for possible presence of extraneous root. So we're going to define extraneous root in our next lesson. Are you guys ready? Let's solve and let's explore radical equations. Let's try to solve and check the following radical equation. So we have square root of x minus 4 is equal to 2. So notice that our radical is already isolated in one place. So our next step is we have to get rid of this radical sign. So what are we going to do? We're going to raise both sides of the equation by our index. So our index here, if you still remember, the index is 2. So we're going to raise both sides of the equation by our index. So that is 2. If we do that, remember the rule, if the index and the power are the same, we can cancel this out, and what is left now is x minus 4 is equal to 2 squared. That's 2 times 2. The answer is 4. Next is we're going to apply addition property of equality. So we're going to add both sides of the equation by 4. So that's now x is equal to, this one produces 0 pair. That's why it's cancelled out. Then 4 plus 4, the answer is 8. So the value of x here is 8, or the solution here is 8. Now let's try to check. If we're going to check if this is correct, we are going to substitute the value of x in our radical equation. So remember, we have square root of x minus 4 is equal to 2. So we plug in 8. That is now square root of 8 minus 4 is equal to 2. 8 minus 4, that is square root of 4, is equal to 2. Then square root of 4 is 2, that's 2, is equal to 2. So therefore, 8 is our solution. Okay, so let's have some more examples. Now let's try to solve for problem number 2. Square root of x plus 3 minus 2 is equal to 9. First is we have to isolate the radical sign. So what we need to do here is we will apply first addition property of equality. We have to transfer negative 2 to the right. So to do that, we will just apply addition property by adding both sides of the equation by positive 2. So bring down square root of x plus 3. Then this is a 0 pair. So it's equal now to 11. Since we already isolate the radical sign, what's next is to identify our index. In our example, the index again is 2. So we will raise both sides of the equation by 2. So we can eliminate this radical sign here. That's now x plus 3. So this cancelled out. And 11 squared, that's 11 times 11. The product is 121. Next is we will solve for the value of x. To solve for the value of x, we need to transfer positive 3 to the right by applying subtraction property of equality. So we will subtract both sides of the equation by negative 3. So this is cancelled out because it produces 0 pair again. Then x is equal to 121 minus 3. The answer is 118. So again, to check if this is correct, we will plug in this value in our radical equation. So from square root of x plus 3 minus 2 is equal to 9. So we have square root of 118 plus 3 minus 2 is equal to 9. So we add this. That's square root of 121 minus 2 is equal to 9. Square root of 121, that is 11. Minus 2 is equal to 9. 11 minus 2, that is 9, is equal to 9. So that is correct. Meaning, 18 is the solution in our problem. Okay? Let's have some more examples. I have example number 3. Right, let's proceed in solving problem number 3. This is the same with problem number 2. So our rule is to isolate first the radicals. So if we're going to examine, we have to transfer negative 2 to the right. So to do that, we will add both sides of the equation by positive 2. Okay, so this is now square root of 3x minus 8. So this one produces 0 pair. That's equal now to 0 plus 2. That is 2. Next is we have to identify our index. The index we have here is 2. So we will raise both sides of the equation by 2. Okay. Next is, since this is cancelled out, if you still remember our rule, if the index and the power are the same, so our answer is the radicand only. So our answer now here is 3x minus 8 is equal to 2 squared, and that is 4. Next, we have to solve for x. To solve for x, we are going to transfer negative 8 to the right. So to do that, we will apply addition property of equality. So this is now 3x. So this is 0 pair is equal to 12. Take note, we need to solve only for x. So we have to divide both sides of the equation by 3. So 12 divided by 3, x now is equal to 4. Okay, so our next step is to check whether this value we have here is the solution or not. Okay, so we will write again the equation or the radical equation. That's 3x minus 8 minus 2 is equal to 0. So we have square root of 3 multiplied to 4 minus 8 minus 2 is equal to 0. So 3 times 4, that is square root of 12 minus 8 minus 2 is equal to 0. 12 minus 8, that is square root of 4 minus 2 is equal to 0. Square root of 4, the answer is 2. 2 minus 2 is equal to 0. So 2 minus 2, 0 is equal to 0. So therefore, 4 is the solution. Okay, so I hope you learned something new today. That's all for now, and I hope to see you soon. Goodbye, class.